Lesson 5.1, roots and rational exponent, nth roots and rational exponents. Let's get started. Previously, you learned that the nth root of a is n, then the radical sign of a, right? Nth root of a is equal to a to the 1 over n power, right? So that's the relationship between rational form or radical form and exponential form. So an example 1, it says to write a to the 1/7 in radical form. So we need to remember that this symbol right here is called the radical, right? So in example A, we're in exponential form, right? A to the 1/7 power. The 1/7 is an exponent. In radical form, we're going to have that radical sign. So that base of A is going to go under the radical, and then this denominator right here, this 7, becomes the n value of that radical, right? So the 7th root of a. If we had an exponent other than, or an exponent with a numerator other than 1, that numerator would then carry down with the a, right? We would have a to the 1, but we don't put to the first power on our numbers, right? It's implied. In example B, we have the square root. If there's no number by the radical, it's a square root. So we have square root of w, and we want that in exponential form. So that w stays as my base, and then it has no exponent of its own, so I'm going to have a numerator of 1 and then a denominator of 2, right? So that's w to the 1/2 power. Write that a little more clear because my fraction bar and my w kind of all connected there, right? So just a quick review of switching between radical and exponential forms. So real nth roots of a. So what we are looking for here, we're looking at the difference between our n value, right? So our n value, so here we have n and a goes underneath. If we have even n values, right, we have 3 different things that can happen here. If you have an a that is less than 0, there is no real nth root, right? If I put a negative number as my a value here, I'm going to get an imaginary number, so no real answer. If my a value is exactly 0 for an n, with my n value being even, then my answer is going to be 0. And then if my a value is greater than 0, it's going to have 2 real nth roots, plus or minus a to the 1 over n power. Then if my n value is odd, and my a value is less than 0, I'm going to have 1 solution. And if my a value is 0, I'm also going to have 1 solution at 0. And if a is greater than 0, I'm also going to have 1 solution, right? So these 2 are going to give you the same solution. So let's look at that in practice a little bit, right? So find the indicated real nth roots of a, right? So I need to put this in a usable form, right? So I can do this one of 2 ways. I can put this into radical form, right? So I draw my radical sign. That's the 3rd root of negative 216. Or I can solve this as negative 216 to the 1/3 power. And in either case, I am going to use my calculator, and Desmos is the better tool here. So if I want to have radical form, on the home screen of your Desmos bottom row, we see the square root sign. and your TIs have the square root easily accessible as well. The nth root is buried in both calculators, and if we scroll down on our Desmos all the way to the bottom to number theory, we see this nth root, right? And that gives me a little flashy cursor to enter that n value. So I need 3, and then negative 216 as my a value. I get an answer of negative 6. If I wanted to do this, if I wanted to do this in exponential form, I can hit this button here in the top row, and then I can enter my 1/3 fraction there as well. Either way, I get an answer for part A as negative 6. For part B, I get the 4th root of 81, or I can do 81 to the 1/4 power. Now, this is an even root, so this is where I'm going to have the plus or minus answer, right? So if I use my calculator here, function, scroll all the way to the bottom, get down to that number theory section, the 4th root of 81, the 4th root of 81, it tells me that the answer is 3, and your TI-83 calculator is going to do that as well. It does not recognize the plus or minus. That's something that you're going to have to do with your own brain, is remember that if you have an even n value, that your answer is plus or minus. If I enter that as a fraction, I'm going to do the same thing, 81. I hit this a to the b power button, and I can enter in the 1/4, and I get that answer of 3. Doing these on the TI-83 is more complicated. You need to make sure you're using parentheses in the right spots, so I would just rely on Desmos. So here we have a rational exponent does not have to be in that form of 1 over n. You can have a numerator other than 1. So if, looking in the blue box, rational exponents, let a to the 1 over n be the nth root of a. Let m be a positive integer, right? So here in our first example, right here, right, we have a to the m over n, and what they're doing here is kind of separating out the numerator and denominator of that exponent. But what we can ultimately do is take the nth root of a and then to the m power, right? So that that numerator in that exponent becomes the exponent after you take the nth root. If you have that negative exponent, just like we talked about previously, negative exponents are on the wrong side of the fraction bar, and they kind of work that all out there for you. Again, it's really easier to see it in action. So evaluate the expression 16 to the 3/2 power. Honestly, you could just plug that directly into your calculator just like that to evaluate it. If you wanted to write that in radical form, right, the 16 goes under this 2, right, square root, and then to the 3rd power. Well, the square root of 16 is 4, and then to the 3rd power, 4 times 4 is 16, times 4 again would be 16 times 4, I believe, is 64, right? I could just enter this directly in, 16, and then I can type in that 3/2 power, not 3/5, 3/2 power, right? And I get a solution of 64. For 32, part B, 32 to the negative 3/5 power. Well, it's a negative exponent, so it's on the wrong side of the fraction bar, right? So the fifth root of 32 then to the third power. The fifth root of 32 is 2, and then 2 to the third is 8. Again, I would just enter this in the calculator. 32 to the negative 3/5 power, and then that is 0.125. That is the same as the 1/8, right? On this, you see here in blue, there's this little fraction icon. You can click that and it will change your answer to a fraction for you if that is the form that you need. So our answers previously had nice whole number answers. We're not always going to have nice whole number answers, so we are asked to use technology to evaluate these, rounding to 2 decimal places. SAT, PSAT, probably looking at 3 decimal places. But again, 9 and then my exponent of 1/5. Right, so there's my answer. Part B, 12 to the 3/8. 12 to the 3/8. Part C. This one's a little more intense to enter, but we can do it. Let's just type it in exactly as we see. See a parenthesis, and then I'm going to go to get that nth root at the bottom of the function list. Right, I want the fourth root of 7, which is going to be a pretty gnarly number there, and then to the third power. Right, so those are my answers. My directions here say to round them to 2 decimal places, so I'm going to go ahead and do that. 1.55 for part A. 12 to the 3/8 is 2.54. And the fourth root of 7 to the third power is 4.30. Right, so I just used my Desmos to work that through. Solving equations using nth roots, raising an nth root power and taking the nth root are inverse operations. So we can solve an equation in that form of u to the n equals d, where u is an algebraic expression, d is a real number. We're going to take the nth root of each side to solve that out. So we are asked to solve these 2 equations. So looking at example A, 4 times x to the 5th equals 128. Right? I am going to solve that like I would any other equation. Right? I'm going to move away the 4. Right? I'm going to divide away the 4. So 128 divided by 4 is 32. So x to the 5th equals 32. Right? To move away this to the 5th power, I am going to take the 5th root of both sides. Right? So x equals the 5th root of 32. If I don't know that, if I don't know what 32 to the 1/5 power is, right, I can plug that into my calculator. I could use that nth root button there as well, right? But I get a solution there of 2. For part B, I don't know why it won't let me change colors, but we'll do it in red. Okay, for part B, x minus 3 to the 4th power equals 21. Okay, so I'm going to start by taking the 4th root of both sides. Okay, that's going to leave me with x minus 3 equals. Well, the 4th root of 21, if I want to type that in directly as it is written, right, I can scroll all the way down and get that nth root. Right, 4th root of 21 right, is equal to, now remember, this is an even n value, so it's plus or minus 2.14. Okay, now when I go to add away this 3, it's going to split into two problems. So x equals 2.14 plus 3, or positive 2.14 plus 3, which would be 5.14. And I would also get x equals negative 2.14 plus 3, right? Negative 2.14 plus 3. X also is equal to 0.86. Right? So don't forget, when your n value is even, you have that plus or minus. Some real life application here, depreciation. Right? So every business wants to know how much their equipment's worth all the time. A hospital purchases a machine for $50,000. They expect the useful life of that machine to be $10, which time it will have depreciated to $8,000 in value. The hospital uses the declining balances method for depreciation. So the annual depreciation rate, R, is in decimal form, is given by the following formula. R equals 1 minus S over C. S is that scrap value, and C is its original cost. And then to the 1 over N power, they say that takes 10 years, so your N value is 10. Right? So looking here, R is equal to R is equal to 1 minus 8,000 over 50,000, that initial cost, to the 1 over 10 power. So they want to know what is that annual depreciation rate then. So we need to solve this for R. We need to essentially do the math, right? So I can enter in that, right? We're going to start in the parentheses. We're going to go 80,000. 80, let me just clear all these out. 8,000 divided by 50,000, right? 0.16. So 1 minus 0.16 to the 1/10 power. So I'm going to go 0.16 0.16 to the 1/10 power. Right, I get 0.832, and then I can go 1 minus that previous answer. So I could even put that up here in the 1, in my 1 minus. Right, so I'm going to get 16.7%. If I left it here, right, I would get 1 minus 0.832. So 1 down here, 1 minus 0.832. Right, so you get a depreciation rate of 16.8% per year. Right, so 16.8%. Right, I'd move this decimal over 2 spots to make it a depreciation rate or percentage. That should be enough to get you started on your assignment. Please reach out to me if you have questions.